Hello and welcome to the Oxford Maths Admissions Test for 2018. This is question 1, part F. A particle moves in the xy plane starting at the origin 0, 0. At each turn, the particle may move in one of two ways. It may move 2 to the right and 1 up. That is, it may be translated by the vector 2, 1, or it may move 1 to the right and 2 up. That is, it may be translated by the vector 1, 2. What is the closest the particle may come to the point 25, 75? So we're told the particle moves in the xy plane. I've already drawn that here with the two vectors. And we're told that these two vectors, or the particle, can only move up and to the right. Therefore, the particle can only move along a line like such. Along these two lines, or within this area. And then we're told to find the closest distance that the particle may come to the point 25, 75. So firstly, these two lines are y equals 2x. Obviously it goes 1 along, 2 up, and this is y equals 1/2 x. So the point 25, 75, if we go 25 along this line, that will give us a y value of 50. So that's 25, 50. So 25, 75 is somewhere up here. Let's say it's there. And we're asked to find the closest the particle may come to this point 25, 75. You might be able to see here that the closest that is a certain distance here. We can actually turn that distance into a radius, with that radius just touching this line here. So we can work out the equation of this circle with the equation of a circle. X minus 25 squared plus y minus 75 squared equals some distance, or some radius, r squared. But we know at this point the equation of the circle equals the equation of this straight line, y equals 2x. So these y values will be the same, so we can just plug this y into here, giving us an equation x minus 25 all squared plus 2x minus 75 all squared equals some radius r. So what we have here now is a quadratic equation x involving x and r values. So this, if we could plot it, would just give us some positive quadratic in this shape, and we're actually trying to find out the minimum value of r as per the question, the minimum radius or the minimum distance between this value and the path that this vector could take. So how do we normally do a question like this where we're trying to find a minimum? Well, we need to use differentiation. So I'm going to differentiate both the left and the right hand side with respect to x. That gives us, I'm just differentiating across the bracket here. This is my method just to keep track of where all the numbers are going. And on the right hand side you'll notice there are no x values, so this just becomes 0. Which obviously helps us out because we'd want to set this to 0 anyway to find the minimum. So 2x minus 25 plus 4 2x minus 75 equals 0. Expand the brackets now. 2x minus 50 plus 8x minus 4 times 75. 2 75s are 150, times 2 again is 300. Just tidy this up a bit now. 10x minus 350 equals 0. which means that solving for x, x equals 35. So there's our x value at this point here. X equals 35. Now to find the y value, well, it just lies along this line, y equals 2x, so y equals 70. So we have a point 25, 75. We have another point down here, 35, 70. So the difference in y there is just 5. The difference in x is just 10. So this is just a good old Pythagoras question to find the hypotenuse. So using Pythagoras' theorem, h squared equals 5 squared plus 10 squared. H squared equals 25, 125. So h equals the square root of 125. 125 is just 5 times 25, which is the same as 5 times 5 squared. So there is our answer, 5 root 5. So that's the closest this particle can ever get to this point here, 25, 75, by just going up and right. And that's that distance, 5 root 5. So our answer here is B. I hope that helps. If it has, please leave a like, comment and subscribe. If it hasn't helped or there's anything you're unsure about, please just leave a comment down below and I'll answer that to the best of my ability in the comments, or I might remake the video. Thank you very much for watching and keep up the hard work.